Hello to all of my pre-calculus students. This is our first lesson that we're going to be doing during these school closings. I just want to mention a couple things before we get started. We are starting a new unit. This unit is going to deal mostly with something called trigonometric identities. Now, the idea of a trigonometric identity is that it's an equation that is true, but that compares two or more trig functions. So it'll compare, let's say sine and cosecant or sine and tangent. And we can use these to simplify expressions, to change the form of expressions, even to solve equations. So that's going to kind of be the main idea that we're working with here, is this idea of a trigonometric identity. Attached to this work, you will see that the first page lists out all of the trig identities that we're going to be using, even some that we won't be using. You can use it as a reference at any time. It's kind of a place where we can compile all of the different things that we're going to be talking about, which is going to be quite a bit. So let's get into it. So the first trigonometric identity that we need to talk about are something called the quotient identities. And these are these two right here. So the tangent of theta is actually the sine of the angle over the cos of the angle, or sine of theta over cos theta. And its reciprocal cotangent theta actually equals cosine of theta over sine of theta. Now, what that means is that we can convert anything that's given to us as tan, sine, and cos into the other by using this identity. And we're going to see a couple examples of that. Now, these down here should look familiar. These are what we used last unit. These are the reciprocal identities. And if you look in each row here, sine is the reciprocal of cosecant, cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent. And again, those are useful because we can convert between the two relatively simply. So let's look at the first example, and we're going to use one of those second identities for this. Now, question number 1 tells us that the secant of theta is negative square root of 30 over 3. And it asks us to find the cosine of theta. So if you remember, if you look up here, we can see this second identity here is telling us that the cosine of theta is equal to 1 over the secant of theta. So in order to solve this, and pardon this wobbling around here, I'm getting used to this thing. We know that the cosine of theta is 1 over secant of theta, which means that all we have to do is flip secant of theta in order to solve this. So negative 3 over square root of 30. Now, we know we can't leave a square root in the denominator, so let's rationalize that. And then we'll simplify it at the end. So negative 3 square root of 30 over 30, which reduces to negative square root of 30 over 10. So that is the cosine of theta. So if at any point we're given secant, we can always convert it to cosine by flipping the fraction or finding its reciprocal. Now the second two are going to be a little bit more involved. We're given the tangent and the cosine. So up here, we have nothing that in these identities here that converts over these identities right here that convert tangent to cosine. But what we do have is, if you look up top, we know that tangent is sine over cosine. So using that identity, we can fill in two of these in sine and solve for sine, which is what we are eventually looking for. So we know tangent is square root of 2 over 4. And we know we're looking for sine of x, but we also know that the cosine is negative 2 square root of 2 over 3. We have a proportion here, so we can cross multiply. 4 sine x, I'll move this up here so you can see, 4 sine x equals, and then we have square root of 2 times negative 2 square root of 2 over 3. Well, if I'm going to multiply these, I can put a 1 there. And we know that square root of 2 times square root of 2 is just 2. So the top of this fraction will turn into, and feel free to pause this at any point. If you are confused about something or if you have any questions, go back, take a look at it, and obviously reach out to me if there's anything that you don't quite understand, because I'd be happy to help you there. So, but the square root of 2 times square root of 2 is just 2. So the top will turn into negative 4 over 3. And then we just have to divide by 4. Using a calculator, we can find that sine of x equals negative 1/3. Okay, so there's example 2. Now, a little bit more involved, but still, we're just using one of the top identities. So let's take a look at the third one and see if we can figure out which one of these things up here can I use in order to solve for secant b if we're given cosecant and we're given cotangent. Well, if I'm looking on the top here, I have nothing that compares these two in the reciprocal identities. But what I do have is that we know that the cotangent, which is given to me down here, is equal to cosine over sine. So let's write that one down. Now, if you want to use theta, you can. These are betas. You can use b. Cotangent of beta equals cos of beta over sine of beta. And the only other thing that we need to worry about is we know what cotangent is. Cotangent is negative 2 square root of 10 over 3. Unfortunately, I have cos and sine, but what we're given is cosecant. Well, if you remember, cosecant is the reciprocal of sine. So if I want to know what the sine is, all I have to do is flip that. So on the side here, I'm going to write sine beta equals, and instead of 7 over 3, it's 3 over 7. So that's what I can put here. And then I put cos beta up here. Now, the nice thing is, from this step, it's the exact same as number 2. So we cross multiply. 3 cos beta equals negative 2 radical 10 times 3 over 7, right? 3 cos beta equals, multiplying the tops here, I have negative 6 square root of 10 over 7. And then I need to divide by 3. Okay, to divide by 3, it's the same as multiplying the denominator by 3. Just a quick little, trick there, make this a little easier for you. So we have cos beta, I'll move this over here, cos beta equals negative 6 square root of 10 over 21, and then these reduce to negative 2 radical 10 over 7. Okay? Again, reach out if you have any questions. I will be posting part 2, which is the back of these notes, shortly. And hope you guys all stay well. Wash your hands.